let's get into the big topic of open source, something that we actually say at Red Hat.
We haven't.
This is so
we
awesome.
are an open culture that believes
actually
in
a big piece
What is that process that a developer, or let's say,
as the Kubernetes ecosystem really boomed.
Hello, good morning, good afternoon, good evening, wherever you are in the world. This is the Ask an OpenShift admin live stream. You may notice that my lovely co-host Andrew is out, and that is because he is saving America at the tower, doing what he does. He had a meeting that he couldn't miss, and so you're going to be forced to suffer through this with me and Robert here, and Andrew will be back hopefully next week. So today we're joined by Robert Lundberg. He's on the the Red Hat OpenShift data science team.
It's a mouthful.
I'm struggling with that. Even when I was trying to type it up, I was having a hard time with that. So Robert, do you want to go ahead and introduce yourself?
Sure. Thank you. And awesome to be here. So I'm, as you said, on the OpenShift data science team, or OpenShift AI, as it's been renamed, where I'll get into that later as a whole what it's called, a whole by itself. But I'm working there as a senior architect for the business unit, and working a lot both with the product and also with the field, since it's fairly new, trying to get it out to customers. So I figure I will come and show how it looks like and how it works, and just geek out about AI.
Nice. Yeah, I love it. And we were talking in the pre-show a little bit, like it's such a broad conversation, right? There's so many different things that we could fit into this bubble, like the AI bubble, right? So I think I'm looking forward to exploring this with you. Like it's super exciting for me. So let's go ahead and do the top of mind topics. So there's not a whole lot going on, to talk about, but I just wanted to go over our schedule coming up. So next week on the 2nd, we have Trilio coming out. And then on the 9th, Andrew and I are going to do a what's new in 4.13 to kind of catch up on, the streams that we missed before, kind of go over all the things that are in 4.13, and hopefully do like a little bit of a demo with some of the HyperShift stuff that I've been working on. So really looking forward to that. And then we've also got Jack from the Scupper team. He's going to come in and he's going to talk about Red Hat Service Interconnect after that. So we've got a lot going on. We've got an action-packed schedule, which is pretty awesome. If there's anything that you guys want to talk about or want us to talk about, or have somebody come on and talk about, send them to me or Andrew. I'm Johnny at redhat.com. And Andrew, this is me right here, Johnny at redhat.com. I'm also on all the socials. So Twitter, I'm JRockTX1. Reddit, same thing. Kubernetes, Slack. And then Andrew is Andrew.Sullivan at redhat.com, and he's also at Practical Andrew on Twitter. And the other thing is, before you get moving over to the data science stuff, we are also, this is an office hours presentation, right? So we're here to answer your questions. So if you've been watching the stream, or if this is your first time, there are no dumb questions here. You know that we love answering questions. We love the interaction with the crowd. So feel free to ask away. Hopefully it's about the topic, but even if it's about OpenShift or it's about Kubernetes or something that we can answer, we will. Robert and I, we're not the experts on everything, but we try. So if we don't know the answer, we know the people that probably do, and so we can reach out internally and hopefully get your question answered if you do have one that we can't get done for you. So with all that, all my crazy energy, Robert, do you want to kick off your stream?
Would love to. So I prepared a few slides and also a couple demos for this, just to showcase how it works like, and also just walk through why we're doing AI at Red Hat, where this comes from. So let me get this into presenter view. And we already covered what is this and who I am, so we'll skip this one. I can cover OpenShift AI real quick and RHODS. What's the difference between them? So Red Hat OpenShift Data Science, that would be RHODS. I'm not going to say Red Hat OpenShift Data Science every time because I'll twist my tongue. But so OpenShift AI is the parent name to it. So Red Hat OpenShift Data Science is one product under OpenShift AI, and with more products possibly coming out in the future or looking to come out in the future. But right now, they're used pretty much synonymously. So let's start with why Red Hat is doing AI, because Red Hat is not well known for being an AI company per se. But what we do really well is infrastructure and platforms for that. So the image we're looking at right now is a fairly popular image from all the way back at 2015. Time goes way too quick. And what it showcases is how the model code and the model itself is just a small part of everything that's needed to get these fantastic AI applications up and running in a reproducible and repeatable manner, or reliable manner. And that can be things such as the server configuration, data collection, feature extraction, data verification, machine resource management, analysis tools, process management, server infrastructure, and monitoring, and probably more things which are not included in here. And what happened very early on with AI, and what still happens with enterprises when they first get into the AI space, is that they often neglect a bunch of these pieces. And AI very early on had a almost infamously high failure rate. A lot of enterprises tried to use AI and it didn't work. They didn't get the applications out. And this is one of the reasons. It might have been that they wanted to build a AI model which predicts customer churn, for example. And they had some really smart people hacking away, building this model in a notebook, and then they didn't really know what to do with it. Maybe they threw it over the fence to some IT person who had to try to get this thing now serving and running, or say that they actually got it up and running. They now have a one-time off model living somewhere, and if that model was trained on data that does not represent the real world, or if the real world changes, which it oftentimes does, the model is no longer accurate, and they would need to somehow replace that model and train a new model on the new data. And if you don't have this system supporting that, you can very, very quickly see where the failure rate came from.
Yeah, and being the guy that was responsible for putting that system in place, right? I was that IT guy that got it tossed over, and I had to get it deployed and maintain it and stuff like that. It's cool to see that this evolution is finally happening, right? Because we back in the day we'd get this thing going, and it's like, okay, I think it works, so it's kind of nice that we're here where we're finally getting this workflow kind of moving along.
It was even worse back in the day when there was. Now we at least have a few standards within AI, right? There are some serving runtimes.
Yeah.
Back in the days that there were not many standards, and many of them didn't work very well. So this is where Red Hat saw that we could come in and help out. You can draw a parallel from this to early development as well, where before DevOps, where a platform such as OpenShift came in and helped a lot to take care of these components, which are not just the model or application code. So we said, let's try to use OpenShift as a platform to build this MLOps workflow or MLOps system on top of. So that's the first piece. The second piece is, okay, if we're going to use OpenShift, are containers actually good for doing data science on? Is this, OpenShift is very much container based. So is this even a match? And turns out that containers are quite excellent for data science. I mean, they're excellent for most development, but what makes them quite nice for data science as well, besides just the standard things, is with how slim they are and with how easy it's to quickly spin them up and down. This is always a benefit, but data science is a field where you can go from experimenting on very low amount of resources to needing hundreds of GPUs for training that model. So it can go very quickly where you need to scale to massive amounts of resources and then scale back down. And if you can do that in a quicker way, you obviously will be able to save more money, or you'll be able to get access to those resources quicker for another project if you're running on-prem. So that's one reason why containers are quite good for this. The second one is how isolated they are in their environments. If you spin one up, as you guys probably know, it's going to run more or less the same every time. You can, of course, connect it to external factors, but ignoring that part, it will work the same way. And with how experiment-heavy data science is, this is also quite fantastic. This makes it really easy to reproduce results and reproduce experiments, which is, we'll see it a little bit when we jump into the product as well. But yeah, another thing from back in the past is you would have this model which you had trained on, and you try to give it to someone else, and they would have the wrong dependencies and everything would run wrong. Nothing new, the same in development, but it's very much the same here as well. Then containers by themselves are often not enough, so you probably want to connect them together into clusters. That's where Kubernetes comes in, coming in with automatic rollouts, rollbacks, and so on. And the really nice part here is how extensible it is. Again, this is great in the data science field because there are so many open source tools in data science. So you can really take your kube flows, air flows, ML flows, what is it called? All the flows and
flows.
Exactly. I don't know why they like flows so much in AI, but you can take all of these and you can use them in your data science workflow, in your MLOps. And then, of course, OpenShift on top of that to come with the standard things such as baseline security, self-service model, GPU support, and we hear from a bunch of customers who are working with Kubernetes, do-it-yourself Kubernetes, and they're doing fantastic things. But sometimes it becomes a bit too much to maintain, or it's difficult to add some of the new components to start slowing down. And that's where OpenShift can help.
Yeah, I think once you start doing things at scale, right, that's where OpenShift really kind of shines. Like when you've got a cluster, maybe two clusters, a handful, whatever it is, right, and a couple of applications, and you're doing things like, okay, DIY, it's fine, it's totally legit, and it's a perfect way of doing work. But then I think once you start scaling out and you've got multiple applications, like dozens of clusters, hundreds of clusters, whatever it is, and you're really starting to like scale and branch out like big time. That's where OpenShift is just it just shines like crazy.
Yeah, for sure. So that's okay. Okay, enough OpenShift talk. I might be preaching to the choir as well. So let's look at. So we had we see this issue with having to get an MLOps platform, and we know that OpenShift could be a good fit. So what we did is created something called Open Data Hub, and Open Data Hub is I think you guys talked about this Open Data Hub earlier, right, in one of the episodes.
Yeah, so on my team, we created a validated pattern based off of medical diagnosis, and they use Open Data Hub behind the scenes. Like, so essentially, they had a Jupyter notebook, they built a model out, and then took that model and built it into an application that gets deployed as part of the pattern. And then another one uses, like, I think it's ODH, but yeah, we've talked about it a long time ago. I could probably actually find the episode.
Awesome. So Open Data Hub is essentially just a meta project pulling in a bunch of these open source upstream projects, such as all the flows again, the Kubeflow, Airflow, and so on and so on, and any other AI tools you might want to use. So it pulls a bunch of those together, just makes them easier to run on top of OpenShift. And this got quite popular. A lot of enterprises started using this and started running their AI workloads on top of OpenShift. And after a while, we started getting requests to support this Open Data Hub, to productionize it. So that's what we did, and that's where Red Hat OpenShift data science comes from. It currently comes in two flavors, a cloud service, which is managed by Red Hat, and a self-managed, which you can deploy on your own cluster and do with as you wish.
Do you know if the on-prem version, does that support disconnected?
Yes, it
It
supports
does? Okay.
disconnected since I think January or February.
Okay, awesome.
And we also you can run it more or less where OpenShift runs, and we're currently we have the microshift as well, right, for edge devices. So we're currently building a slimmed down version for serving, which can go out to these microshift devices and help you just have a serving layer and serve models on these edge devices.
That's awesome.
So that's so that's where OpenShift data science comes from, and it's since it's a curated version of Open Data Hub, it doesn't contain everything Open Data Hub does. We take a few of the components and we put them into a nice little UX, and it essentially gives a very good baseline for your MLOps platform. And the cool part about this one is you can also grab in other components. So say that you want to use Airflow for your pipelines, for example. You could integrate that as well and use those pipelines, and then use OpenShift data science for serving and model experimentation, for example. But before I keep getting ahead of myself, what's actually inside of OpenShift data science? So we have model development environments, and I'll show. I'm just briefly going through this now, and we'll very soon see in the demo how they actually look like and how they work. But there's environments for model development. They're baseline notebooks, but you can also build custom notebooks, custom notebook images, which makes them very, very customizable. So you can make your notebook looks like VS Code or RStudio or whatever your fantasy lets you do with them. Then there's model serving and monitoring. So after you experimented with your model and you built something which you want in production, you probably want to be able to serve it somehow, and that's where model serving comes in. Just point to the model which you built, and it'll pull it in, start serving it, and give you metrics monitoring on it.
Awesome.
Then lifecycle management gives you pipelines for data science. If you've done DevOps, you're well familiar with pipelines and the benefit of those. Works very similar here. It gives you, at the very least, continuous delivery of the pipelines, so you can trigger them at say that your data is shifting, for example. So the data you keep getting in starts changing. It doesn't look like it looked like yesterday, for example. You might want to retrain your model. So you can then kick off a training pipeline and get a new model into production automatically.
So do you know what is using OpenShift pipelines behind the scene, or is it something that's built in like custom for the data science platform?
It's using OpenShift pipelines. So it's Kubeflow pipelines, and you can use it. So the full stack is Elira at the very top if you want to use it. And that's a drag and drop pipeline builder using Python files and Python notebooks. That sends it to Kubeflow pipelines, which then sends it to OpenShift pipelines. So when we kick off a pipeline, we'll see it run in OpenShift pipelines as well.
Okay, awesome. And then just for everybody that may not know, like, can you give like the 1,000-foot view on like what retraining a model means?
Oh, of course. So and these models, AI models in general, you feed in some data and you get a prediction, right? And to build one of these models, you feed it a lot of data and you tell it what prediction each data sample should give it. It should give for that one. So you send in a dog and you tell it this should be a dog. Very simplified, but you do that a lot and the model starts learning what's what. That's called training. Now, if it no longer predicts correctly, let's say that dogs all of a sudden look different in the world, or more realistically, you want to train it to recognize another dog race. Then you might want to retrain the model, meaning that you do the training process again to teach it this new dog race so it can classify that one correctly as well.
So it's a flow, right? So that way it's always it's keeping up with everything that's going on, you know, so that way, like you said, if there's a dog with 5 legs now, it'll see that and it'll say, oh, okay, this is a 5-legged dog now, but it'll still call it a dog.
Exactly. So that's the magic with the pipelines, right? You can gather this new data and you can just train the model automatically or semi-automatically whenever you need to.
Gotcha.
Going a little bit deeper into rabbit hole as well, we also have something called fine-tuning, so retraining just trains the model from scratch, and fine-tuning takes the existing model and just teaches it only on the new data. So two different ways of modifying the model.
Is that for efficiency, or is that just it's probably an efficiency thing, right? Is that?
Yeah, so some models are quite large, ChatGPT, for example, and you might not want to retrain it every time you want to change it. So a very good way to teach it new data is to fine-tune it. And fine-tuning can also, so you can have these models which are really good at, say, recognizing a bunch of different images and objects. And then you fine-tune it so it now is really good at recognizing a specific object which you're interested in. So two application areas of fine-tuning, you can extend what it knows, or you can focus it on your application area.
Nice. So we do have a question, and it looks like Frank answered it, right? So one of them was, with data science, is it possible without a data lake? And Frank answered like, yeah, it's possible, but it's essentially you're going to run into issues sooner or later. And just to read out what he's saying, he says data lakes are not necessary per se, but they provide a more flexible schema mechanism than traditional data stores. And then Dwayne also asked, does the edge version of the RHODS deployment, does it use Kafka or is it using another technology?
That I can tell you better when it's more developed.
Okay. So Dwayne, keep that question in mind, and keep it looks like it's not completely hashed out. So once we get there,
we have someone who's very focused on this area as well. So I'll ask them if I don't know if I have any way to reach out to Dwayne, but I would be more than happy to ask and get an answer for it.
yeah, I've got his email, so I'll hit you up. I'll connect you two after this.
Awesome.
Yeah.
All right.
All right, that's it. No more questions for now.
Awesome. The last thing on this slide is collaboration. I already talked about increased capabilities, which you can plug in other tools, and the platform is designed to be modular, right? Collaboration gives you projects, which are you have access control and all of those good things in it. A project is essentially an OpenShift namespace, so you can they're very separated, and this is one of the main enhancements we do when we pull in from, sorry, swap to Swedish there for a second. When we pull in from, for example, from Kubeflow, pipelines and environments are not natively don't have projects natively in there. So that's one of the upgrades we do to make it more enterprise ready.
Awesome. And I lied. We do have one more question.
Yeah.
Nick was asking about the slides. Are we going to be able to share these, or do you have like a condensed or a customer-facing, public-facing version that we can share out after this?
These ones we can share. So these are all pulled from our customer-facing deck.
Okay. So Nick will post these to SlideShare afterwards. And then now we got some questions for now. What's the data provenance tool for your models to validate research reliability and reproducibility? That's from Dwayne.
The data provenance tool. So we provide environments and tools around it, so you can get models into production, preserving in pipelines, and so on. The tools you want to use for the models themselves to, and we do have a few things to help with bias detection and things like that coming in, but largely the tools you want to use for the models to improve them and to validate them is very much up to what your preference is.
Yeah.
So you have full access to environments to experiment in, and dependencies you need for it.
Yeah, when I was reading that out loud, I was like, oh yeah, okay, this is probably going to be like a like you bring your own ingredients, right, kind of thing.
Yeah, we as I said, we're giving a few tools later on for insight into the model and so on, but it's very much bring what you prefer. Yeah. we don't want to set limits there.
And then RHODS, he asked, what would be the Red Hat preferred open source data lake solution?
That maybe Frank can answer that better if you're still in the chat.
All right, we'll give Frank a chance to answer. But do you want to continue? I'm going to go out on a limb and say ODF, but yeah, that's just me.
I think so, but we'll see. We'll see if Frank has another answer. Cool. So all of this put together gives you a baseline platform or baseline tools to kind of build MLOps platform on top of OpenShift. And the really cool part with it is, as I mentioned before, it's also hybrid, so it works across the hybrid cloud. And because it's on OpenShift, it kind of brings everyone together. So you have the IT ops, data scientists, and application developers now all on the same platform. So it's easier to manage. You can build workflows that pull both the data scientists and application developers, both of their workflows together. And it unlocks a bunch of cool things from that. And this one just shows a very simplified version of an MLOps workflow, and where you can pull in different tools. So, for example, OpenShift Data Science covers model development. It has serving, so you can integrate it in the application development workflow. And we have monitoring and management already a little bit, and more coming out. But we don't have too much on the gather and prepare data side. So that's where you can plug in someone like Starburst or the AMQ streams. And even on the parts where OpenShift Data Science do cover, you can still plug in things such IBM Watson for AutoML or Intel OpenVINO for accelerated hardware. And that's kind of how we want to build it out. So it's modular, so you can pull in these tools which you need and which are well fitted for your MLOps workflow, the one you need to build.
And just so everybody knows, AMQ streams from Red Hat, that's the that's Kafka, right? That's our rebranded Kafka.
So yeah, that's the slides I had to just introduce the topic. So let's jump over and actually see how it looks like. So I created a little environment for us to play around in. And if you install OpenShift Data Science.
Are you able to expand your window a little bit more?
Oh, sure. I usually get complaints that it's the opposite, it's too expanded. So is that better?
Yeah, and if you could just zoom in a bit, yeah.
How about
that looks fine for me. So it looks like it's good on YouTube. So yeah, we're good.
Awesome. Let me just resize there as well. Okay, cool. So if you install OpenShift Data Science, you'll get this little option up here where you can enter the portal. And the first thing you see when you enter it is going to be these enabled applications. In this environment, I only have Jupyter, but if you add more things, such as the GPU add-on or things like that, it's going to show up here as well, and it'll act as a little portal for you to get to different applications that's connected with OpenShift Data Science. So, and this Jupyter specifically is quite nice for just quickly launching an environment and playing around with. So here you can, for example, select your notebook images with different dependencies in them. You can select the deployment size, and these are t-shirt sizes, but they're customizable as well. So just making it easy to give a few different options. Environment variables, and if I had GPU enabled here, you would see a drop-down for that as well. But this just spins up a single environment, and what you might want to do instead is create a project. So these are the projects I talked about before. Remember, each project is a namespace, so it's very easy to go in and manage them and make sure that only those who have access to it should. So I have two different ones here. I have one for object detection and one for customer churn. So I figured we would speed through them both real quick to show two different, one showcases serving and the other one showcases pipelines. So let's jump into object detection. And this is how it looks like inside a project. So in every project, you have access to all the different resources. You have the workbenches, which are environments. You have storage for these workbenches. You have data connections, which are an easy connection to an S3 bucket. I'll show very soon how it looks like and what you can add, but it's essentially so if you have a model on, I don't know, on ODF in a bucket or on AWS, you can very easy just create a data connection and plug it into your workbenches and your pipelines and your model servers, which are the two last resources, pipelines and model servers. So let's create a workbench and see how it looks like.
Now, real quick, it creates these projects within data science. If you were to go into OpenShift and do like an OC Git project, is that what you mean? Like it actually creates like a legitimate project within OpenShift, or is this all contained within the RHODS interface?
These are actual projects in OpenShift, actual namespaces. So you can jump in and browse through. You can see your different pods which is spun up. You can manage the resources, all that good stuff.
Okay, gotcha. Yeah, I heard it and I understood, but then I started questioning it, so I just had to ask.
That's one of the very cool things, because you can make one of the projects much more than just a data science project. So in one of them, for example, I installed MinIO. I was too lazy to install ODF. So I got that one installed and built a few applications in there as well, which we'll see soon. So you can really tie the data science projects together with whatever you do in OpenShift.
Awesome. And for those that don't know, MinIO is it's an object storage emulator, essentially, right? Like it takes storage and presents it to your cluster as object storage. So it's a pretty cool little project.
Yeah.
Don't know if it's production ready, but like it's definitely something. If you're kicking the tires on something and you need object store and you don't have S3 or an object storage local, then MinIO it's an awesome tool.
It's very handy to spin up and get something quick running. So let's create a workbench for this object detection. So I'll enter a name I spelled wrong. There we go. And we get to select the image, just like we saw before. And the images have different versions as well. Deployment size, I'm going to leave it on small so we don't break anything. We don't need any environment variables. You get a cluster storage preset already. And this just contains your environment files. So if you pull in something from GitHub into your environment, they'll be stored there and things like that. And then I will connect it to a data connection. So this is how the data connection looks like when you set it up. So you provide it with a name, with an access key, a secret access key, endpoint, a region, and a bucket. And behind the scenes, it's nothing magical. All it does is just save these environment variables. So it'll be easy for you to reference throughout your project. So I already have one set up, so I'll just connect to that one. And the one I'm connecting to has a object detection model in it and a few images which we can use. So then the create was hidden. There we go. Then we press the create and it'll start spinning up. And while we're waiting on that one, did we have any more questions, or we're all good for now?
I think we're all good on questions. Keith had made a point that if you're a customer, an OpenShift customer, and you have OpenShift Platform Plus, then you get ODF, and I think it's like ODF Foundations. I can't remember the exact amount, but I think it's a couple terabytes or something like that of storage, and you can use block, file, or object storage, right? So he's just making the point that you get all of that with your OpenShift Platform Plus subscription. And then RHODS 9 just asked, as we always like end users that can use resources responsibly, is there any simple way for the end users to understand how much their workload is consuming? So is there like through the monitoring, are they able to actually see like, okay, I'm using like 40% of the cluster, or like
Very good
I'm killing
question. So for the serving, the monitoring lets you see how much resources your served model is using that you can keep a track on. For the environments themselves, well, first of all, they get to choose how much resources it should use. It won't say how much it is from a total, but as an admin, you'll probably set it up so they have access to not larger t-shirt sizes than you would expect someone to use, right? So they kind of limit it in the t-shirt sizes in that
Okay.
way. And the other thing you can do is you can have culling on these pods for the workbenches. So you can automatically turn them off if they are active too long, or sorry, if they're inactive too long. Or you can just shut all down at midnight, for example, to free up resources that way.
Gotcha.
So this
That's awesome.
It's we have one customer, Boston University, who very much utilizes that, where they have they go from needing 0 workbenches or 0 resources up to 300 people using them all at once, and then they have so they have some tools for spinning up all these workbenches really quickly, and they also have tools for culling them down after the lecture is done.
Nice.
So let's open up the notebook and
Yeah, and so just for everybody that's listening, Keith made a point about if you have OPP, you get 256 terabytes of ODF. It's pretty dope. That's a lot of
that's awesome.
That's a lot of terabytes. Thanks, Keith. Appreciate that.
Okay, so this is how your environment looks like if you don't customize it too much. And in here you have if you ever used a Jupyter notebook, this will look very, very similar and familiar to you. So what we're gonna use now is just this this Git feature to quickly pull in a GitHub repo for the object detection. Go. And we can open up some file and just run it quick to see how it executes, and it's actually quite fast. So the other thing, so we have this data connection, right? And we connected this to our workbench. So what we can do is we can take that that model which we stored in the bucket, and we can run inference on that one. So actually, let me back up a little bit. I jumped forward one too many steps. So we'll before we start running or inferencing on this serving model, I'm just going to simply pull down the model and run a local inference on that. Yes, essentially just run data through the model and see what it predicts. And as an object detection model, hopefully it detects some model in the image we send in. So we don't need to go through all of this, but this is the little image, this cat. And what we'll be doing is grabbing these environment variables from our data connection from over here, and then pull in the model. And finally, we will run a prediction on it and int it. That's a quick example of just the object detection model running live. and how you can use the data connection together with it.
Nice. And the cool part about this too is like with the notebooks and everything, and then I know we keep going back. I keep bringing it back to OpenShift, and it's not on purpose, mostly. But like with you can build an image stream that will import the notebooks into the image stream, and then you can redeploy that image out of your workbench here, right? So like, say you had some Jupyter notebooks that you guys that all right, this is my core thing that I want to use, right? This is the base of my that everybody needs to use or whatever. You can build those into an image stream, and then that image stream becomes available as one of the images in your workbench that you can use. So say I can't remember the one that you selected, right? You have one that's like maybe it's just Jupyter, or you have like the CUDA. It would actually be part of this list here as long as you had access to it, right? And you could have like the Kitten's core or whatever, and then it would just import like that base those base notebooks. So I think that's pretty awesome that you can have all that stuff integrated. Because it goes back to that story that you were telling in the beginning, right? Like it's the reusability, it's the repeatability and stuff like that, without going back and rebuilding your dev environments and stuff, right? So this is how it all starts to kind of like tie together and present itself to the interface.
Exactly. So that's a great way to get your custom images into here. So the second part I want to showcase here was the serving. Now to serve a model, you first set up a model server, and the model servers they have a serving runtime, it's called. And what this essentially does is encapsulate the model and execute it, right? So here we currently have OpenVINO, but you can, just like custom notebooks, add in custom serving runtimes. So if there's something missing, you can add in, for example, the really large LLMs, they usually use their own custom runtime. LLM stands for large language model, which is ChatGPT or similar. So if you want to serve one of those, you might want to pull in your own runtime here. So I created one with OpenVINO here, and then I deployed a model to it. And as I mentioned before, to deploy a model is simply just selecting what type of model it is, and then selecting where the model is stored. So in this case, it's this S3 bucket and a specific path. And then I will pull it in and start serving it. And if everything goes well, it will look something like this, where you get a little endpoint and a loaded status. So if we copy this one in and continue this script and enter this here as our prediction URL, we will be able to run a prediction through that endpoint instead. So that's, you probably don't serve a model just to run it through your notebook, but that's just a way you can test it. Now, to make this a little bit more realistic, I also took one of our demos, which hosts a little application for this model. So we can take a quick look at that one as well. So I have it deployed here. And what this does, it's these two. And what these do is, the first one here is simply just a interface to your serving. So this one takes any request it gets, it reformats it a little bit, and then sends it to the serving endpoint. And then we have a front-end application which takes pictures and sends them through this interface to the serving and all the way back. So we can open this up and take a picture. And I'm 76% person, so that's good news. So that's only part of my face, though. So, so that's an example of this, it running in an actual application and how you can tie all of it together. Now,
that is awesome.
And if you know more about OpenShift, you can probably start optimizing these ones with pipelines as well, and start tying that into your different served models, and when you push out new served models here, and start tying those two workflows together really nicely. Which
Man,
leads
yeah.
us, yeah. Sorry, go ahead.
No. Go ahead. I'm sorry. I'm just the nerd in me is like getting all excited.
It's I love to demo this because it's so so much fun to play around in it. That leads us to the last feature I haven't really showed, which is the pipelines. And as mentioned before, it's pipelines just for data science workflow instead. So I'm gonna jump into our other project, our customer churn, where I already have a workbench running, and I have a data connection to the local min.io I mentioned before. And this one just acts as a pipeline storage. And what we can do now is start running pipelines. So if I open this workbench up, I have a very tiny one created here. And what this does is it downloads some data and processes it. It will then train two models, one with, I don't remember what the full name here is, gradient boost, right? One with gradient boost and one with random forest. And finally, we'll compare both of them, and it will push the best one of them as the best model as a pickled file in this case. Now, I'm just pushing this model to our min.io storage, but you could just as well push it to whatever place you're hosting your served model from, and push out a new served model whenever you need it. And if we run this one, we'll start it. I might need to refresh this. Let's see. Should start the run, see the run starting. Okay, maybe we don't see it here. Let's jump into the pipelines for customer churn. Okay, here we go. So we now have a new run which has been triggered. And we can jump in here and we can see it running. And as you mentioned before, we can also jump into the pipelines here. It might need to be an admin. And start seeing it here.
Very nice.
So that's how they tie together. And just backtracking real quick, we'll, oh, I don't have that here. You can also import pipelines. So this is if you build custom pipelines and you don't want to run them from your workbench. The workbench I ran here is Elira. And as I mentioned before, Elira will convert this to a Kubeflow pipeline, which then goes into the OpenShift pipeline. And this gives a really nice interface for data scientists to just easily drag and drop, in this case, notebooks, but Python files as well, but also giving a lot of access to other settings, such as what data should transfer in between them, what environments do I want to use, how do I want to run it, in which runtime, not runtime, in which image, and so on. And I think the last thing we can do is just look at the min.io to see things got uploaded. So that should be here. That's not the right one. Here we go. And we have our little pipelines bucket. And I don't know which one is the new one, so we'll click one and just look into that one. And we can see here all our files from the run, all the artifacts, as well as the new models, such as the best model.pickle. We can also see the random forest model and the gradients boost model. So you have access to all of this. And they also give I think this is from Elira. They give a really nice little interface for debugging it. So if I don't know how to show this because I need to download it, I believe. Yeah, I can't show that here, but if you download this and look at it, it'll show you your little notebook and give you all the outputs and the potential errors.
Nice. The cool thing, like I'm not a data scientist at all. Like you probably picked up on that, right? I'm kind of dumb, but like the cool thing is that you don't have to be an OpenShift or Kubernetes guru to do this, right? Like you just go to this workbench, you do your thing. It looks like all the options are there. Like if you need to add all your connection points and stuff like that, that's pretty awesome. Now, and I assume that like anything I can do in the UI, I can also do in YAML as well, right? Like if I am that kube nerd and I just want to do CLI stuff, right? Like I can dump all this out to YAML and then redeploy it that way, right?
Oh yeah, so all of these are OpenShift resources, Kubernetes resources. So you can deploy all your different projects, access control, or your different workbenches fully from your CLI if you prefer that.
Yeah, this is awesome. This is really awesome. So if people wanted to like learn about this, right? Like are there any resources that are out there that they can go to and just kind of kick the tires with it, or do they have to have a subscription, or can they use like the developer subscription? Do you know?
So there is there are trial subscriptions you can try out for it, and so you can try it really easy. It's available in your let's see, in your operator hub. So you can just find OpenShift Data Science here, and it's literally one button to install, so you can very quickly get it up and running.
Okay.
For resources, we have a few really good videos out there, and we also have this website called AI on OpenShift. And this in here you can find a bunch of material on Open Data Hub, OpenShift Data Science, AI, a few how-tos, different tools like Min.io. I just went down and copied this one to get it into my project. But also other things such as all the flows we were talking about, Airflow and so on, patterns, and then demos where you can load them quickly into your OpenShift and start running some AI.
Damn, that's awesome. And in the upstream, the upstream is Open Data Hub, right? So
exactly.
Yeah.
So how that works is Open Data Hub has a fair bit more components than we have in OpenShift Data Science. So we have different tiers of tier 0 is everything that's in OpenShift Data Science, and then we have another tier where we incubate the different components that are about to go into OpenShift Data Science, and a few which are only in Open Data Hub for now. And you can find all of that on the Open Data Hub website.
Nice. Damn, that is awesome, man. Like this is awesome. Can you share this website URL? Like
Oh yeah.
Like I put it over here in our private chat. If you just paste the link.
Which chat? Sorry.
It should be. You should. Well, excuse me. In the restream, you should see a private chat.
Let me maximize. There we go.
Yeah, there we go. Cool. All right. No, this is really awesome. So like my experience has mainly been around like Open Data Hub, and Open Data Hub was awesome. You know, like it did everything that we needed it to do. But there's still some like there's some massaging, right? It looks like this has got all the knots worked out, you know, to stay within the massage conversation. But like, it's cool to see that you've got this interface. You can go through and you can work all your magic, and then you don't have to know all the back end stuff, because I feel like that's where a lot of like hesitancy comes from to like adopt something like this, because you're like, oh, well, I've got to know OpenShift, or I've got to know Kubernetes, or I've got to know all this stuff. But when you go in and you have this, you're like, hey, look, here's this UI. You just go click the buttons, add the connections that you want. And as an admin, right, which is I think most of us, or a lot of us, hopefully, and you know, those that aren't, hopefully you don't have to do it. But as an admin, I can also control like those levels, right? Like, hey, I don't want you know, Johnny to have the 2XL, because I know even though he's a medium, he's always going to take the 2XL because like databases or whatever, you know. So I think having that kind of control from an admin perspective, and then having that kind of control from the user perspective, because it still feels like you're empowered to do your job without being limited by the tool, right? And I think that's just that, excuse me, friend, that's awesome.
Yeah, that's the self-service part of it for the data scientists, and that's one of the main goals of OpenShift Data Science, is very easily being able to get access to resources you need and the tools you need. So making it easy to get pipelines and get the workspaces, or even integrate tools outside of RHODS for the admin. So that's one of the things which a lot of people so far enjoy with it with RHODS.
Yeah, I think that's awesome. And Frank, I just saw a comment that Frank made where he says data scientists are the rock stars and IT ops are the roadies. Like, that's 100% accurate, right? Like, that can't have rock stars without roadies, can't have roadies without the rock stars. So yeah, I totally agree with that. That's awesome. So Robert, like we were kind of talking before we got started here about like some of the scope, right? Like we were talking about like the object detection and all the things that you can do with that, and large language models and stuff like that. How far do you see this going? Like, where, because just in my little bit of experience, right? And I don't even want to call it experience, but I've only chipped the surface in a couple places, right? Like we've done some projects where we're doing like object detection, where we're taking images in, and it's essentially looking at an X-ray, and it's making a determination like, does this person have pneumonia or not, and then it's outputting that to a dashboard. And some of the other ones we're doing more like data monitoring, where you've got like sensors in a factory, right? And those sensors are showing like, oh, hey, look, your data center has just, you know, the temperature just rose by like 30 degrees or whatever. You know, that's probably terrible, but it's taking all this information and it's actually giving us something that we can use and then make a decision off of. But then on top of that, now we've got all this automation in there, right? So it's like, okay, well, look, if this is what's in the output, then go do this thing. And if it's really bad, then call me, right? It's the take 2 Tylenol and call me in the morning pill, or you know, automation. So I'm just curious, like how far do you see this going? ChatGPT is awesome. It's become a household name, right? Like it's everybody knows what ChatGPT is, good, bad, or ugly, right? Like they know what it is.
Yeah.
So I'm just curious, where do you see it all going? Like the object detection, you know, video detection, all that stuff.
It's it's a good question. It's we're definitely not going to see it slow down if that's what you're wondering. It's so we saw ChatGPT and the explosion of that one. We're probably very soon going to see more multimodal versions of ChatGPT, which means it takes it doesn't just take text, it also takes images, which it already does to a point, audio, and can output those different things as well. And at some point, I mean, it's already predicted that the majority of enterprises will incorporate more and more AI. And as they get better and better, it's to the point where it comes to your imagination, right? How far it will go.
Yeah.
At some point, we'll probably all just sit on a beach and look at the AI work, right?
Indeed. Yeah, and all the Red Hatters are going to be like, dude, you have Lightspeed, right? The Ansible Lightspeed, where you say, hey, write me a playbook that does this thing, you know, and then there's gonna be the Kube stuff that comes out. Like there's just so much. It's awesome. And like I've seen some external projects where they're doing like a Kube GPT or something like that, or chat, I can't remember what they called it, but it's essentially the same type of
cool
model for Kubernetes resources. Yeah, so I mean it's awesome, man. Like the whole environment, the whole thing is just, it's mind blowing that we've come this far, you know.
Yeah, it's in the near future, at least, we're gonna do a lot less hassle. Leave more time to be creative and work on the higher controls while the AI does the details. I can also quickly show. I had one more slide which just shows where RHODS is heading. So we talked about ChatGPT, and one thing which we're doing, obviously, you know about the light speed. So what we're getting more and more in here is distributed training and serving for these large language models. So you can fine tune, you can prompt tune these models and get the entire lifespan of these really huge models as well into your MLOps system. And so that's something we're really excited about, and combine that also with the deployment to edge devices and things such as the model bias detection and model prediction explanations, which coming in as to, again, make it easier for the scientists to get the entire lifespan up and working.
That's awesome. Yeah, the distributed training, that's awesome, right? I mean, you think just from a medical perspective, you know, if you're trying to train, just using the X-ray story again, right? Like, you've got all these medical facilities everywhere, right? Like pop-up emergency rooms, you know, med clinics, all that stuff, right? They can take an X-ray, they can send it into this model, you know, make their determination locally or whatever, and then send it into this model, and then that way, next time, or maybe even that time, who knows? Like at some point, they can use that and say, hey, look, okay, nope, you're good to go. Doctor had it right, or you know, hey, maybe we need to review this with you know, like an actual doctor, not a radiologist or whatever, or with a radiologist, not a doctor, whatever, whichever way it works. But it's cool because like right now we're kind of like the model is happening locally, or it's happening, you're sending it off and it's happening in another environment and then it's coming back. But like to have this distributed thing where all these resources can come in and send their stuff out, or even do their stuff locally and then pop it up somewhere. That's awesome.
Yeah, having a fleet of factories or edge devices which stream monitored data back to your whatever you want to call your headquarter data center.
Yeah, exactly. It's so, man, it's awesome. I do have, you know, I'm nice to my, so I have a Google Home, and I'm really nice to it because, you know, like when it comes back to take over, you know, I just wanted to remember that Johnny was nice to it and I never yelled at it. So, because it's gonna be some Skynet stuff.
The same as saying thank you to ChatGPT. It's make sure it remembers.
That's right. That's right. Give it the little fist bump. So I don't have anything else. I mean, I could sit here and just ask you a bunch of dumb questions because I have a bunch of them. But I don't know if there's anything else that you want to cover or anything. But this was, to me, this was awesome. I really appreciate you coming on, you know, and taking the time. I know it's late in the day for you, so yeah, I appreciate you taking the time for this.
It was a ton of fun. I've shown everything I want to show for now, so it's. If we have any questions, just hit me with them. I'll see what I can answer.
And I'll put you in contact with Dwayne, and I'll update the video with the slide share link for the slides.
Awesome.
So with that said, if there's no more questions, we will go ahead and end the stream. Again, we'll see you next week. It'll be Andrew and I. We have Trilio coming on. Oh, I was about to do this without. Okay, this is where I'm getting terrible. So if you want to follow our stream on YouTube, go ahead and like and subscribe. The link to our playlist is here. And also, Andrew and I were over in the OpenShift users Kubernetes Slack, which is here. And then I'm also over in the OpenShift Commons. OpenShift Commons is more of like that's the OpenShift community, right? So if you have any questions or if you have anything you want to talk about, like we're over there as well. So here's the workspace to OpenShift Commons. So go ahead and hit us up. Let us know. If you want to get a hold of Andrew, and you don't have his email or whatever, or, my goodness, I'm sorry. If you want to get a hold of Robert, not Andrew, I got Andrew on the mind, Robert. I'm sorry. If you want to get a hold of Robert, hit me up and let me know, and I'll connect the two of y'all so you know, you can ask him questions. But yeah, other than that, we got Trillio next week. It's going to be an awesome month. August is going to be great. Robert, thanks again for coming on. This was super informative for me. I really appreciate you walking through the UI and giving the presentation. So thanks again.
Thank you very much. I have one last resource to link.
Yes, do it. Do it.
You can find here, if you want documentation for RHODS, we have a bunch of them. So here is written documentation on how to get started and everything like that, and the changes. So I'll link that as well.
Drop it down, I'll pull it over. And then Frank said that there's an AI channel over in the OpenShift Commons Slack workspace. So what I'll do is I'll update the video description with the workspace to the channel. Oh my goodness, the URL to the channel. And so that way we'll have OpenShift Commons in there, and then we'll have OpenShift Commons to the AI channel. And then that way, if you want to join up and talk to these guys, like that, they'll be out there. All right, awesome. Well, that's it for me. Again, see you next week. Robert, thanks again, man. This was awesome.
Thank you very much. It was great.
All right, have a good one.
Take care.